U.S. Department of Transportation logo, Federal Highway Administration.
Welcome to the Complete Streets Safety Analysis webinar. RJ, if you could please advance to the next slide. So on the screen, hopefully now you're seeing as a disclaimer. I won't read it to you, but I will give you an opportunity to read it yourselves. But in summary, the presentation was created and being co-presented by FHWA and the contractor, but doesn't necessarily represent the express views of the Federal Highway Administration or the U.S. Department of Transportation, DOT. It's disseminated in sponsorship with the DOT, more for the purposes of information exchange. It does not constitute a standard, a specification, or a regulation. And furthermore, the government doesn't endorse necessarily these products or manufacturers. Any sort of trademarks or names that appear in here are because they're considered part of the presentation itself. More for informational, and does not, again, represent a preference, approval, or specific endorsement of any one product or entity. So I'll leave this up here for a few more seconds for you to read. Just want to make sure you've all had a chance to understand that. Okay, and with that, I'd like to hand over the presentation to Dr. In-Kyu Lim. And so with that, please take it away.
Thank you, Alan. Good afternoon and good morning, everyone, depending on where you're at. Welcome to the Complete Street Safety Analysis webinar. We are very glad that you could join us today. This is In-Kyu Lim at Federal Highway Administration, Office of Safety and Operation R&D at Turner Fairbank Highway Research Center. As many of you are already aware that previous announcements that FSWA decided to adopt a complete street design model to improve safety for all road users, especially for vulnerable road users, as one of the NRSS National Roadway Safety Strategy outlines. And this research task is a part of that effort to identify and compare and evaluate existing CMF, combining method with CMF to quantify safety performance using complete street case study. Various complete street related study and activity are currently undertaking at FSWA, and these activities are receiving a lot of support and special attention from leadership. So we have Barbara McCain with us today. Barbara is a senior policy advisor in FSWA Office of Safety and co-leads the internal complete street working group.
Thank you, Dr. Lim.
Yep, thank you.
I'm really glad that we're having this webinar. This project has been in the works for a while and really stems back to our report that we wrote for Congress about 2 years ago, looking at what we, Federal Highways, needed to do in order to help make safety for all users our default approach as we move forward. And one of the things we identified, really a couple things we identified, were a lack of safety data and a lack of analytical techniques that help us measure the safety benefits of providing safe infrastructure for all users. In particular, we noted that a common tool that we use, the crash modification factor, looks at one countermeasure at a time, when very often multiple countermeasures are installed at once when a complete streets project is underway. So this research project is a first step towards helping practitioners determine the safety benefits of projects that make multiple changes to provide for safe travel for bicyclists, pedestrians, and transit users. And you will be hearing about the research project and some case studies that were put together around it and the forthcoming Complete Street Safety Analysis primer. We look forward to continuing to work with the practitioner and the research community on improving our ability to conduct robust safety assessments for transportation projects. So we'll really be interested in your feedback and response to this project. I'm going to give it back to you, Dr. Lim.
Okay, thank you, Barbara, for your support and great message. And I think we are ready to start the presentations. I would like to introduce presenter Dr. R.J. Porter from VHB. Dr. Porter is a senior transportation engineer and lead this research project at TOPI. Actually, I just remind that we will have a Q&A at the end of the presentation, but you also can use the Q&A part if you have any questions during the presentation. Also, please mute your microphone and turn off camera for improving network bandwidth. Dr. Porter, please take it over and begin the presentation. Thank you.
All right. Well, thank you for the introduction and welcome, and definitely thank you all for being here today. I appreciate the opportunity to present an overview of this Complete Streets Safety Analysis project to you. This slide gives you an overview of the flow of this presentation. I'll begin with a little bit more background on Complete Streets that will set the stage for this particular project's motivation and objective. I'll then highlight some of the different activities and products of this project, and then conclude with the overall findings and recommendations. FHWA describes a complete street as one that is safe and feels safe for all users. Planning, design, and operations of complete streets and complete streets networks prioritize safety, comfort, and connectivity to destinations for all users of the network. FHWA is developing resources to help make complete streets a default approach to designing non-access controlled roadways, and is leading efforts to identify and overcome challenges and capitalize on opportunities to grow the implementation of complete streets. These opportunities include advancing knowledge on data collection, analysis, planning, and performance measures that support complete streets implementation. Complete Streets prioritizes safety for all users and seeks to design and operate streets that minimize or eliminate the chances of fatal and life-changing injuries. In this way, Complete Streets are very much aligned with the safe system approach, and this is very much different than, say, a more historical idea of thinking about safety versus operational trade-offs. There's great momentum to build on when it comes to Complete Streets. According to the National Complete Streets Coalition, in the last 20 years, hundreds of jurisdictions across the U.S. have adopted complete streets policies directing their agencies to plan, design, and build complete streets. We'll talk about the elements that can be part of a complete streets transformation here a little bit later in the presentation. The transformation shown on this slide comes from one of our project's safety analysis case studies in Florida. This transformation involved adding mid-block pedestrian crossings with rectangular rapid flashing beacons, one mid-block pedestrian crossing with a traffic control signal, LED lighting, pedestrian refuge islands, bicycle lanes, raised traffic separators, and median landscaping. The timing is certainly critical for advancing complete streets. NHTSA has estimated more than 42,000 traffic fatalities per year in 2021 and 2022. Not since 2007 had annual U.S. traffic fatalities exceeded 40,000. Each year, pedestrian and bicyclist fatalities comprise about 19% of all traffic fatalities, and there's certainly a great need in the U.S. for safer streets for all. The 2021 House report on the subject's appropriations bill encouraged the adoption of a complete streets design model in which roads and streets are designed and operated to enable safe access for all users. It also directed FHWA to review its current policies, rules, and procedures to determine their impact on safety for road users, particularly those outside of automobiles, and to report their findings. The resulting report to Congress, moving to a complete streets design model, identifies 5 areas of opportunity for Federal Highway and its local, tribal, and state transportation stakeholders. FHWA's Complete Street Initiative seeks to increase the proportion of projects built with federal aid funds that are safe for all users. And so with that background and context in mind, we now get to the specific motivation of this project. There's been significant growth in methods that agencies use to quantify the expected safety benefits of a project. And the term data-driven safety analysis, or DDSA, is often used to characterize these safety analysis methods. DDSA was an everyday counts innovation. Crash modification factors, or CMFs, often play a critical role in DDSA. A CMF is used to compute the expected change in the number of crashes at a location after implementing a safety countermeasure or some other type of change to a site. CMFs are sometimes created for specific crash types and severities. Other times they apply to all crash types at a more aggregate level. So for example, combining all types and severities. I'm showing one example of a CMF here on the slide, a CMF specific to vehicle pedestrian crashes for implementing a lead pedestrian interval at an intersection is 0.81. This means that implementing an LPI is expected to reduce the number of vehicle pedestrian crashes at the intersection by 19%. CMFs are developed through different types of studies, usually looking at a sample of locations before and after a change of interest occurred. The study designs and analysis approaches for creating quality CMFs is a full field of study in itself. However, Federal Highway has created and now operates the CMF Clearinghouse, which seeks to be a practitioner-friendly resource for identifying and applying appropriate CMFs. Some agencies have created their own agency-specific CMF list, selecting CMFs from the clearinghouse that are most relevant to their needs. And so continuing the project motivation, one set of challenges and corresponding opportunities for implementing complete streets are based on a need to improve methods for quantifying the safety performance effects of multiple safety treatments that agencies implement together on complete streets projects. More specifically, Federal Highway's report to Congress highlights that the ability to fully quantify the impacts and benefits of pedestrian and bicyclist safety treatments on the safety performance for those users is limited because the availability of CMFs for pedestrian bicyclist crashes is also relatively limited. In addition, complete streets transformations usually include multiple treatments implemented in combination. For treatments where CMFs do exist, methods to combine multiple CMFs to estimate that overall safety benefit of treatment combinations are still at relatively early stages of testing. And, even with the rapid growth in complete streets interest, these safety analysis gaps can sometimes limit the ability of planners, engineers, and decision makers to fully quantify or fully see what the multimodal safety benefits of a complete streets project will be. So being able to identify and address these gaps would help support broader implementation of complete streets projects, including more widespread applications beyond local roads. A complete street safety analysis needs assessment that tries to characterize current capabilities and identify needs will be a useful step towards achieving this vision. So that gets us to the objective of the project that I'll be talking about for the rest of today, which was to provide practitioners and other complete street stakeholders with a resource that first identifies and describes what are our current capabilities and best practices, but also identifies what are our future data and analysis needs for quantifying the safety performance effects of multiple safety treatments that agencies implement together simultaneously during conversion of typical streets to complete streets. The focus of the project was on treatments expected to improve safety of pedestrians and bicyclists. However, these same treatments may also affect the safety of other road users as well. We have a report that's in the publication process. It's expected to contribute to progress towards some of those goals in the report to Congress, but most notably to the goals in that report regarding studying multivariable CMFs to support context-sensitive safety analysis and issuing new guidance on safety analysis and performance to support rigorous safety assessment during project development and design to help prioritize safety outcomes across all project types. The project consisted of the activities that you see here shown on the slide. Those included identifying pedestrian and bicyclist safety treatments that agencies implement together on complete streets projects, determining which of the treatments currently have quality CMFs for different crash types and severities, characterizing, assessing, and evaluating methods for combining multiple CMFs, documenting the effort and preparing a safety analysis primer to help practitioners conduct DDSA using our current CMF capabilities, but as I mentioned, also identifying gaps and future directions for safety analysis of complete streets. We're also in the process of developing some additional marketing and outreach materials to further share our project findings. So the first part of this project focused on characterizing safety treatments that agencies implement together on complete streets projects. Our project team was located throughout the U.S. and drew on its previous complete streets policy and project experiences to identify a geographically diverse sample of candidate complete streets projects. The projects were both from urban and rural areas, and the scope of this effort focused primarily on arterials with speed limits of 55 miles per hour or less. In addition, Federal Highway Administration shared a sample of candidate projects from another ongoing task order that was focused on characterizing construction cost for complete streets projects. Using a combination of project documentation, satellite imagery, we collected a range of information for each project, including the elements that you see here on this slide. Ultimately, this approach resulted in data for 85 projects. Based on the project documentation and satellite imagery, our team identified 80 potential safety treatments across the 85 Complete Streets project. An appendix of our report documents all 80 of those treatments, including treatment definitions with example pictures. Based on an initial assessment of the 80 treatments and looking at some initial results and the focus of this effort, our team concluded that it could be beneficial for the purpose of this CMF analysis and needs assessment to combine treatments that were named differently in project documentation, but where it was likely referring to similar treatments or treatments that had common goals. We also, just for this next step, removed treatments related less to safety performance in terms of crash reduction and more related to user comfort, aesthetics, and ADA compliance. While these types of treatments are absolutely critical and central to a complete streets approach, our effort was focused on quantitative crash-based safety performance evaluations that create CMFs, and being able to do so for those treatments may not be possible or practical in the near future. And so we'll circle back to those treatments when we get to some future analysis directions and metrics that could be used to more fully capture the benefits of complete streets projects. So the result of the screening and then a consolidation of treatments was 35 treatments that we organized into 4 categories that you see here on the slide. Example, pedestrian bicyclist treatments included things like adding a separated bike lane, adding or enhancing pedestrian and bicyclist signal operation. Example, transit treatments included adding a bus island or floating bus stop, adding bus rapid transit. Example, treatments in the traffic category included things like adding or enhancing traffic signal operation. And then example treatments that would fall in the roadway configuration category included things like changing parking configuration, performing a road diet, or reducing the number of lanes. So first, just a high-level look at some of the data highlights. This table shows the total number of treatments applied on each project as part of the Complete Streets transformation. As you can see here, more than 75% of the projects that we looked at implemented at least 3 treatments, with about 62% implementing between 3 and 6 treatments and 14% implementing 7 or more treatments. As mentioned earlier, most CMFs were developed by researchers evaluating 1 treatment at a time, and there's very few CMFs available for these types of treatment combinations that we're seeing on Complete Streets projects. So this starts to give some insight into one of the motivations of this project to explore ways to apply multiple individual CMFs to capture that safety effect of treatment combinations. Here's one other example way to look at our project data separated by area type and treatment category. Again, some high-level insights. A majority of the projects we looked at were from urbanized and urban areas, but we did have some rural area coverage. The most common combinations of treatment categories across the projects were combinations of treatments that spanned pedestrian, bicyclist, and roadway configuration categories. That was 44 of our projects, followed by treatments that were just in the pedestrian bicyclist treatments only. That was 20 of our projects, followed by combinations of treatments that span both of those categories, as well as traffic improvements. That was 11 of our projects. We then did an analysis of the most common specific treatment and treatment combinations from the list of 35 treatments. For treatment combinations, we looked at the most common combinations of 2, 3, and 4 treatments across the sample of 85 projects. We have this information summarized across a number of tables and exhibits in our report, and just giving you a quick snapshot here on this slide to show you how to interpret that information. We show here the 6 most common treatments across the 85 projects across the top of this slide, with the number of projects that had that treatment shown next to it. And then for each one of those most common treatments, our analysis would show the most common combination of 2, 3, and 4 treatments, including that most common treatment. And so, for example, adding or enhancing a sidewalk was a treatment on 29 of the 85 projects. Adding or enhancing crosswalks was used in combination with adding or enhancing sidewalks on 15 of those 29 projects. Adding or enhancing lighting was a treatment with adding or enhancing crosswalks and sidewalks on 8 of those 15 projects. And then finally, those 3 plus adding curb extensions or bulb outs were used together on 6 of those projects. For practical purposes, we did not extend this beyond 4 treatments. Hopefully you could start to see here how this nicely sets the stage now for testing our current CMF capabilities. We could ask, do we have CMFs for these 4 treatments that you see at the bottom of the slide? And if we do have CMFs, how can we combine the 4 individual CMFs to estimate the safety effect of the combination of the 4 treatments? Before we get into that piece, I just wanted to quickly describe one other path we took to uncover treatment combinations of interest. The methods and results I described so far was more of an empirical approach, looking at a sample of project data to arrive at those common combinations. However, we also thought it would be beneficial to arrive at common treatments by more of a diagnostic approach and thinking about common crash types leading to fatalities and serious injuries on arterials, and then thinking about treatment combinations applicable to different area types, facility types, and project types. For example, is it a full reconstruction, or is it more of a 3R retrofit that would influence the types of treatments that might be part of the transformation? And so we used our team's subject matter expertise here, but also 2 relatively recent references were super helpful for taking this diagnostic approach too. One was Federal Highway's Complete Streets Transformations document, and then the second was there's a scenario appendix of the 2022 Atlanta Regional Commission Regional Safety Strategy, which provides a great presentation of different types of treatments of interest. After we went through this process, in general, we did arrive at very similar results as we did with the more empirical approach using the project data. And so we saw the diagnostic approach as validating the results of the empirical approach. We had common treatments and treatment combinations that we arrived at using both. We did identify several additional treatments that were not part of our sample of projects that you see here on the slide that we then added to our list of treatments of interest, including decreased roadway or lane width, removing a shoulder, converting flush median to a raised median, and adding a bus island or floating bus stop, or adding a bus boarding platform. So our next activity then, we had these treatments and treatment combinations, was an assessment of current CMFs for quantifying the safety performance effects of the common complete streets treatments. And we compiled available CMFs for the initial list of 80 treatments from the FHWA CMF clearinghouse. Ultimately, we identified and collected a total of 718 CMFs across the 80 treatments. Certainly, this is a substantial number that support the ability to conduct DDSA of complete streets now. But there were also some limitations, as you'll begin to see on some of the subsequent slides. One such limitation is there were some common treatments that still do not have any CMFs, and we have those listed here on the slide. A table from our report shown here summarizes the availability of CMFs for the 15 treatments that are part of our most common treatment combinations. plus those 4 additional treatments from the diagnostic review. And again, an appendix of our report will provide a summary of CMF availability, including number of studies, number of CMFs, CMF quality, and crash types and severities of available CMFs for all of the 80 treatments. Just a few quick interpretations of this table. First, after multiple decades of CMF-related research, there remains some significant CMF needs with respect to quantifying the safety performance effects of complete streets treatments for all users. The table shows one common treatment, curb extensions and bulb outs, has no CMF at all. Of the 15 treatments in this table that do have CMFs, the maximum CMF rating for 7 of the treatments is lower than 4 stars. And this is an indication of at least some significant limitations in the research that created the CMF. Treatments expected to improve both pedestrian and bicyclist safety performance do not always have CMFs for both of those specific crash types. And then finally, only 3 of the treatments have CMFs specific enough to focus on fatal and suspected serious injury, or KA crashes, which are the primary focus of the safe system approach. Without CMFs specific to KA crashes, analysts need to assume that the effect on KA crashes is generally the same as the effect on, say, your KABC crashes, so your fatal all the way through your minor injury crashes. Such an assumption could be okay, but it may sometimes also mask some specific effects that some treatments might have that are beneficial on the most serious crash types. These CMF needs exist not because of a lack of research, but because of a lot of inherent data challenges in developing CMFs for pedestrian and bicyclist safety treatments, and we'll hit on some of these challenges and potential future directions towards the end of the presentation. So following that CMF assessment, we could see, though, that capabilities existed now to conduct data-driven safety analysis of complete streets, even if perhaps not at the level of detail we would ultimately like for some crash types. And so our next set of activities was to move forward with a full safety analysis on 5 case studies. This would include testing different approaches for developing an overall CMF for treatment combinations using those treatments' individual CMFs. As I had already discussed, we had gathered information from 85 projects from across the U.S., including data on each of those projects. This information was used by our team to screen the full list of Complete Streets projects and select 5 case studies. The selection criteria focused on projects that had at least 3 years of crash, traffic, and road data available before and after construction. The project focused on improving pedestrian and or bicyclist safety and connectivity. And the project had been constructed with 2 or more safety treatments for an individual site or a project area. Finally, since these projects served as a basis for testing methods of combining individual CMFs, it was also desirable for the projects to include treatments with known CMFs. Based on these criteria, the research team selected the projects that you see here listed on the slide for the more detailed case studies. For each case study, our team collected project information and data to perform both a predictive safety performance analysis as well as a safety performance evaluation. And so the predictive analysis is the pre-construction application. So analysts want to estimate the expected safety performance of a proposed complete streets project in comparison to an alternative condition, say the no-build condition. These projects were obviously already constructed, but we could pretend to go back in time, back into what would be the project planning stages, and conduct an analysis that would predict the safety benefit of the project. The safety effectiveness evaluation is the post-construction application where the project has been constructed and the analyst is interested in estimating the safety effectiveness of that completed project. So these case studies allowed us to see which methods gave us the most accurate predictions compared to what ultimately happened. To do this on each project, our team divided the project into segments and intersections based on the segmentation process similar to that in the Highway Safety Manual, Part C, and we assign crash, traffic volume, geometric, and treatment data to the relevant segments and intersections in both before and after periods. For each of the treatments, we identified the most applicable CMFs and then explored 5 different methods for determining CMFs for treatment combinations. So here's one example of a segment on our First Hill streetcar project that shows the changes on this segment occurring from before to after the complete streets transformation. You can see the treatments on this segment, including adding shared lane markings, removing on-street parking, adding a median, adding mid-block crossing, adding pedestrian signal, and adding streetcar facilities. And so in thinking about that, predictive safety analysis would ask specific to this example segment, what would be the safety performance of this segment in the future no build condition? In other words, no complete streets transformation, that top picture, versus what would be the safety performance of this segment with this combination of treatments. And then the evaluation piece after the project is built is just slightly different. What would be the safety performance of this segment in the future no build condition versus what was the actual safety performance of this segment after implementing this combination of treatments. A few more highlights here without going too into depth. One part of both the predictive analysis and the safety evaluation involves trying to estimate what would have happened to traffic volumes had the Complete Streets project not been built. In other words, what would be those future no build volumes? And there's not a perfect way to do this. There are options, and agencies have their own practices for doing this as well. You can see that we looked at 2 different approaches for the predictive analysis and 3 for the evaluation. We termed these P1 and P2. Again, different ways to go about that volume prediction for predictive analysis, and then E1, E2, and E3, different ways to go about that volume prediction for the evaluation piece. The predictive analysis options P1 and P2 is also where the different approaches for creating a CMF for treatment combinations fits into this as well. And we explored, as I mentioned, 5 different methods for determining CMFs for treatment combinations, and these methods are fully described in our report. Because of the limitations in available CMFs that we previously discussed, the case study analysis focused on total crashes, in other words, all types and severities. In other words, changes in pedestrian and bicyclist crashes are aggregated with changes in other crash types to determine the overall change. Again, not necessarily ideal. You'd love to be able to key in on some of those specific crash types as well to complement those overall results, but our current capabilities don't allow us to do that for the treatments that were on these case studies. This is a big table that shows the evaluations E1, E2, and E3 at the top of the table, representing what actually happened on the 5 case studies with respect to crash reductions, and then the predictive analysis, pretending that we were able to go back in time into that project planning stage and what we would have predicted at the time. That's at the bottom of the table. And then different methods for combining CMFs for the treatment combinations are part of this table as well. You see here shown on the slide things like the dominant common residuals and the dominant effect and so forth. Just overall, big picture takeaway was that the 5 case studies generally illustrated closest agreement between predictive analysis and actual safety outcomes using either what's called the dominant effect or dominant common residuals approaches for identifying the appropriate CMF to represent the safety effect of different treatment combinations. So the best way to go about combining those individual CMFs. And this is consistent with other DDSA resource documents that indicate that these 2 approaches are most appropriate for situations where there is significant overlap in the crash types that are addressed by the individual treatments. And certainly that is the case for complete streets. This highlight one example here of our findings on from our Highways 28, 29, 104 project in Glenwood, Minnesota case study, which was a rural town complete streets case study. The predictive analysis using the dominant common residuals or dominant effect methods for creating a CMF for the applicable treatment combinations predicted a 27% and a 38% crash reduction, respectively, for this project. Those are the two boxes at the bottom of the table that showed our predictive analysis results. And the project actually experienced a 39% crash reduction when looking at the evaluation. That's that table or a box at the top of the table. So again, our prediction was between 27 and 38% crash reduction, and the actual reduction was 39%. So with those, again, we had 5 case studies by combining DDSA principles with what we learned during this project. One final activity was the creation of a complete streets safety analysis primer. The purpose of the primer is to summarize how to estimate the combined safety effect of multiple treatments for complete streets projects. And as noted already, the primer focuses on 2 applications: that predictive analysis, the pre-construction application, which is allowing analysts to estimate the expected safety performance of a proposed project in comparison to the no build, and then how to go about a safety effectiveness evaluation. That post-construction application, allowing analysts to estimate the safety effectiveness of completed complete streets projects. Following the discussion of the analysis methods for the 2 applications, the primer describes the data needs and preparation, common challenges and limitations in existing data and methods, and future research needs. We see 2 target audiences for the primer: the first, practitioners; the second, researchers. Hopefully, practitioners can use the primer to estimate the safety benefits of proposed or completed complete streets alternatives. Researchers can use the primer to evaluate safety effectiveness of constructed complete streets projects, or to identify and address the challenges related to current data and methods. Just a little bit more about each application. The predictive analysis section applies to projects that are not yet constructed. Again, analysts could use the methods in this section of the primer to estimate the expected safety performance of a proposed complete streets project with multiple safety treatments. The predictive analysis includes 3 steps that you see shown here, which are described in more detail in the primer, which is estimating the safety performance of the future no build condition, determining a crash modification factor for the complete streets project for those combination of treatments, and then estimating the safety performance of the complete streets project. The first step is to estimate safety performance of the study area for future no build conditions, and there's several options for methods to estimate that future safety performance of the no build condition, including various combinations of observed, predicted, and expected number of crashes. And so we provide a flow chart and a discussion of the process for analysts to select a method based on the availability and reliability of their historical crash data, and whether or not they may have calibrated or jurisdiction-specific safety performance functions for the study area, facility type, and site type of interest. And then the second step is where the analysts will often need to select or estimate a CMF to represent that combined treatment effect. And the primer focuses on the dominant effect and the dominant common residuals methods, given those findings of our case studies. The safety effectiveness evaluation applies to projects, again, that are constructed, and analysts would use the method in this section to determine the success of the complete streets project, so determining or estimating the overall improvement in safety performance. The safety effectiveness evaluation includes the 2 steps that you see here shown on the slide: estimating the safety performance in the after period if the complete streets project had not been built, so without the project, versus comparing that to the safety performance in the after period with the project. Again, we provided a flow chart and figures and discussion of the process for analysts to determine the methods most appropriate for them based on their data and analysis capabilities. I've alluded to this throughout the presentation today. The presentation provides you with some high-level highlights. Our report contains significantly more detail on each of our activities, and we tried to organize the report such that a reader could go to a section or a chapter of interest without needing to read everything prior to that section or chapter of interest. Our report concludes with identifying existing challenges, limitations, and future directions and opportunities. The limitations and challenges generally apply to both the predictive analysis and safety effectiveness evaluation, unless otherwise noted. One common challenge is the lack of reliable safety performance functions for some of the facility and site types that are parts of complete streets projects. And this includes whether there are state or jurisdiction specific safety performance functions or calibrated safety performance functions from the Highway Safety Manual. SPFs are used for some, but not all of the safety analysis methods covered in the primer. And so this limitation ultimately influences the safety analysis method that can be used. Traffic volume data may not be available for all years and on all segments and intersecting cross-street legs. We had challenges on some of these case studies because we had gone back in time for the before data, sometimes a decade or more. And certainly we have some new data and technologies that are improving for our ability to address the traffic volume need in current times. Pedestrian and bicycle data is definitely very much needed for a full analysis when analyzing the safety performance of complete streets projects, especially when estimating those specific safety effects on pedestrian and bicyclist crashes. However, we certainly saw a related challenge on the availability of pedestrian and bicyclist volume data. These data were difficult to obtain on these case studies or simply not available. If pedestrian or bicyclist volume data are not available, analysts can still analyze the safety performance of complete streets projects, but won't be able to account for any changes in pedestrian bicyclist activity over time. As I briefly highlighted earlier, part of DDSA involves accounting for changes in traffic volume over time. However, it could be difficult to determine the volume changes that would have occurred without the complete streets project. The variations in the predictive analysis and safety effectiveness evaluation methods. Again, we tried some different ways to go about estimating those volume changes. Analysts may need to make assumptions when attributing volume changes to the complete street project versus what would occur without that project. A complete streets project may result in changes to the surrounding networks in terms of travel demand by mode. For example, if a project reduces traffic volumes along the project corridor, some of that volume may have switched travel routes or may have switched to other modes. And so to understand the full effects of a complete streets project, analysts may need to expand the study area to include the surrounding network and be able to estimate those changes in demand. And then the final challenge I'll mention here today related to the lack of CMFs is specific to the predictive analysis application. If you don't have CMFs available for one or more of the treatments, then you're not able to estimate those potential benefits of those treatments. And I had already previously covered as part of that table the CMF limitations related to some of the specific crash types and severities that we're interested in. Our report documents other potential analysis directions to start to think about for complete streets that could provide hopefully some additional insights to complete streets benefits, including broader public health benefits. And we included some of those on this slide that we've mentioned in our report. The first could be a set of safe system-based metrics that could capture what are more foundational outcomes that complete streets treatments are trying to achieve, such as reducing exposure, capturing not only volumes, but the length over which users interact, trying to develop metrics that capture the increased separation between users, whether that's a physical separation in space or in time, metrics that capture how these treatments manage potential collision speeds and collision angles, and then metrics that could capture how the changes in treatments reduce the complexity for all users. It could be possible to collect these more fundamental performance outcomes on a representative sample of roads, combine them into one or more composite metrics, and then relate those more foundational outcomes and composite metrics to crash frequency for different crash types and severities. As previously noted, the project team removed treatments related more to user comfort, aesthetics, and ADA compliance, where quantitative safety performance evaluations may not be possible or practical. However, these treatments also bring substantial and significant key benefit, and so including higher levels of accessibility for all users and attractiveness for all users. It may be possible to capture these types of benefits in addition to crash benefits with more comprehensive performance indicators, of which reduced fatalities and injuries would be one part of those more comprehensive health performance indicators. And this slide shows a couple of potential examples. And so with that, I just wanted to, before wrapping up, conclude with highlight some other key resources that, in addition to our report, would be helpful for carrying out the types of analysis that we discussed today. Have a long list of references that I've cited throughout. And so with that, I think we have some time left, and happy to field some questions. And again, if we don't get to all questions, we will have a record of them, and we'll look forward to providing answers in some form here.
All right.
Alan?
Thank you, RJ. Yes, I was just clicking on something on my other PC to make sure we can see everything. So thank you all for those who had submitted questions into the Q&A. If you've not noticed that there's a Q&A pod module down below, feel free to expand that. You should be able to see all of the asked and answered questions. There are several. You might need to click a toggle to see not just yours, but all answered questions. So feel free to click on that. There's some really good ones in there. I won't read them all aloud, but just as an example, are we going to be able to get to PowerPoint to this reference? Yes, we are. What speed did you use? What speeds did you use? Was crash modification factors between bike lanes and such? Let's see, another comment about accessing the full report, which is great. Enhancing crosswalks and so on and so forth. So what you may want to do is, if you're a PC person, Control A for select all, Control C for copy, and save those results in a document. Or if you're a Mac person, Command A, Command C. But as we mentioned, we're going to try to share out the full proceeds of this at the conclusion. There are a couple questions in the Q&A pod that I'm going to read aloud in just a moment, as we got about 10 or 11 minutes or so. Also, if there's anyone in the audience who wishes to ask their question verbally, please look for the raise hand button down below. You can click on that, sends a command to us that you'd like to speak. And when the time is right, we'll kind of call out your name, will allow you to take yourself off mute and ask a question that way. So I do see, let's start with one or two open questions in the typed Q&A. One comes from Joe. Joe writes, on slide 13, you mentioned about less on safety. Can you expand on that?
Yeah, thanks, Joe. I think that was when I was working through, when we had started looking at our sample of 85 projects, we had developed those 80 treatments. There was a grouping of treatments that, at least for the time being, we saw that could be difficult to explicitly link to crash frequency. They had other very beneficial purposes, but for the purposes of sort of assessing our current CMF capabilities and needs, we put those treatments to the side for that step of the project. And so that's I believe that's what I was referring to by treatments focused less on safety. I should have maybe been a little bit more explicit and detailed of, maybe where we couldn't see that in the near future there would be a possibility or practicality of conducting a CMF evaluation.
All right, thank you for that, RJ. We do have a hand raised, so we'll go to that, and then we'll come back to some more typed questions. Looks like Alem Hagos. Alem, hopefully I'm saying your name correctly, but if so, please correct me if I'm wrong. You can now take yourself off mute.
No, you're good. Okay. You're good. Thank you. Alem Hagos with the Law and Hampton. My question is this. I believe your study included facilities posted or operational speed of 50 or 55, right? Am I right?
Our primary focus was arterials with speed limits of 55 miles per hour or less.
Okay, so here is my question. 55 is expressway speed. Why would even pedestrians be there? Why even bother with complete streets? Frankly, I mean, unless the speed limit is reduced on an expressway, I mean, why should pedestrians, bikes, or anybody be there? This is just like, a general question. It's not specific to the study, but I would imagine I was involved in one small project which required a complete streets approach. But the speed limit was 35, and we were actually trying to reduce it to 30 miles per hour. Thank you.
Yeah, I think we wanted to, have the possibility to again capture those arterials where there certainly a mixture of uses and needs that have grown over time, and so there's opportunities on arterials to implement complete street approaches. We wanted to look for examples kind of focused on that speed category, but certainly we sort of had a full range of posted speed limits across our projects, but that just helped us set that initial criteria. Let's go see if we could find examples where there were complete streets transformations on projects that in the before period had speed limits of 55 miles per hour or less.
Okay, thank you, RJ, for that. Let's see, next we have another question from a different writer. Matt writes, how did the predictive model perform when compared to post-evaluation?
Yeah, that's a great question, Matt. So I guess a couple of ways to answer that. Sort of my general takeaway, and I haven't been aware of too many efforts that as our sort of highway safety manual and those types of methods have grown over time, sort of going back in time and seeing how well they perform. And sort of our general takeaway was that the predictive analysis was generally, in the ballpark for providing reasonable results that you might need at that project planning stage. We did see again, we only tested this for this project on a handful of case studies, 5 case studies. For a couple, we were very close in terms of the predictive performance versus what actually happened. On the other few, there was a little bit of a range of over prediction of crash reduction from the CMFs. Now, part of that could be related to some of the assumptions I was talking about how do you project sort of what the traffic volume changes would have been in the future. There's a relationship there between that and how well your predictive analysis will perform. But again, sort of a general takeaway is that there were some reasonable results in terms of the prediction versus what actually happened.
Great, thank you, RJ. We do have another raised hand, and then we're going to have a chance to maybe get to a few more types of questions. So we'll start with another raised hand is Anthony Benvenga. Anthony, hopefully I said your name correctly, but please correct me if I'm wrong. You should be able to take yourself off of mute and then ask your question or share your comment.
This was very enlightening. I have an incident where out in the Midwest, in Kansas City, I think it is, where they took one of their main truck routes and did complete streets, and they screwed everything up royally. What's going to happen to businesses that get messed up basically because of these complete streets?
Yeah, I mean, I think from a broader perspective, I think sort of well beyond this presentation today, but certainly a heavy stakeholder engagement is part of the, I'd say, a complete streets approach from that planning level, where an area might be looking at their needs and their network connectivity to a programming level, where projects are being prioritized, and then to the design, and certainly at the construction stage too. I think, the resources that are out there from federal, state, and local agencies speak to certainly a need of heavy stakeholder engagement throughout.
Yeah, I was going to jump in on this one because this is definitely beyond the scope of this study, which is very much focused on looking at the safety analysis in order to make decisions about what's going to be really help reduce our fatality and serious injury rates. You can look, we have a number of resources on our Complete Streets page from the planning end of federal highways. There's a bunch of case studies there about that show some very positive impacts, economic impacts, and other impacts from some of these treatments. So you might check that and watch for other information about that topic on other webinars that we're presenting.
Thank you.
All right. Let's see here. All right, we got time for just a few more. Joe in the Q&A, looks like Michael has maybe started an answer, but we'll see if our RJ can take care of it. On slide 17, you mentioned about shoulder removal. Can you expand on that more in context?
Hey, Joe, good question. I think that was, one potential possibility looking at when looking at reallocation of space, say within a given right-of-way boundaries, and that could be sort of one option, a shoulder removal to provide space for another facility or additional buffer. And so if memory serves me correct, that possible treatment was one from the Complete Streets Transformation on Arterials report that could be a possibility on some road types.
All right, RJ, thank you for that. We do have one more hand raised. I just will point out that anyone who's entered a question into the Q&A module, rest assured that we will still capture those. We might not get to all of them today, but we will receive them as part of the meeting archives that we generate. So don't think that it's going to disappear into the ether. We'll certainly capture it, but we will take at least one more hand raise at the moment, and then we'll see if we have time for one more after that. But it comes from the hand raise I'm going to look at is a Ryan Kroons. Ryan, you should now have the ability to take yourself off mute and share your question or comment.
Yeah, thank you very much. Great presentations. Thank you guys very much. I have an observation. I know when we're adding a sidewalk or shared use path in an urban area where you're taking pedestrians or bicyclists off the street, you would expect to see a safety improvement, a CMF. But in some urbanized or the suburban areas, when you add a sidewalk shared use path, you're actually bringing pedestrians to a road that probably did not have it before. In other words, pedestrians probably were not using these facilities before because there was not really a place for them. So sometimes I guess the improvements is not necessarily in safety improvements as in CMF. It's more accessibility and probably, better health outcomes and those kind of things. So just like when you're adding a new roadway segment, there was no road before, adding a new roadway segment, you're getting more crashes. Is it a bad thing or a good thing? Just an observation.
Yeah, if I could react, if that's okay, a couple of points there. Is certainly, you're exactly right that sort of looking at more holistically at the various benefits is certainly key. But I do think there are some other literature out there. So on these 5 case studies, we struggled to get at some of those changes in non-motorized user activity. We had a couple of our case studies where we were able to get some information, but there's also some other interesting research out there. I think we again sort of may automatically assume that as we increase those volumes and that level of activity, there would be increased crashes. But there's been some other work noting something called the safety in numbers effect, that actually that additional non-motorized user volume can change overall driver awareness of those users and just the overall behavior. And I think there's some interesting research out there that shows that increase in volume doesn't necessarily mean an increase in those crash types, particularly for non-motorized users. So I do think it's a question that we absolutely need. We could use some more research, more data, more analysis. But to the point you're making, I personally don't draw that linkage just yet. And I have one of the studies that we've published using data from Charlotte and the Highway Safety Information System showed this effect in that area as well. So I'd encourage you to take a look.
And I'll add to that there's public health research that really shows a lot of times what we have is situations where there are destinations, there's housing, there's grocery stores, there's other destinations people need to reach. And if there are low income communities, they often do not have automobiles and they are walking alongside roadways, and you can actually see those goat tracks that those desire lines. And that's a much more common situation in the United States than a situation of attracting new use in a lot of these arterials that we're talking about.
Great. Well, thank you both for that. I will say that we were about 2 minutes over the hour. We certainly appreciate all of the questions and comments that come in. I'm watching my attendee count drop. I'm guessing people have got other meetings and other priorities to attend to. So with that, I think I'm going to pause the response to the Q&A and hand it back to Dr. Q and Dr. Porter, and to kind of close us out.
Yep. Okay. Thank you, Alan. Thanks for asking for the great question. And then actually, this study contains a lot of contents. So if you read the final report, you will be able to understand the scope and then the effort of this research task. But actually, the final publication of this research is under internal editorial review, and then it will be available in December or early next year so you please visit to the FHWA Complete Street website. I also hope you to take away what you are looking for from this webinar, and please don't hesitate to contact me if you have any questions about today's webinar. Also, for the next, this is not the end. Actually, Complete Street Safety Analysis Phase 2 project focusing to propose and develop more practical approach that can fill or improve identify the gap from this Phase 1 will begin from next month. And we will also schedule a webinar and invite you to share the findings once it is completed. So that could be your end of next year or the following years. Thank you for your participation again, and have a wonderful remaining day. Thank you.
Thank you, everyone.
Learn more at www.fhwa.dot.gov. Follow the Federal Highway Administration on Facebook, Instagram, Flickr, LinkedIn, Twitter, and YouTube. The U.S. government does not endorse products or manufacturers. Trademarks or manufacturers' names appear in this video because they are considered essential to the objective of the video. They are included for informational purposes only and are not intended to reflect a preference, approval, or endorsement of any one product or entity. Except for any statutes and regulations cited, the contents of this video do not have the force and effect of law and are not meant to bind the public in any way. This video is intended only to provide information to the public regarding existing requirements under the law or agency's policies.